At 6:44 in the morning, a single missile leaves a fixed coastal battery on the Iranian shoreline, and the Abraham Lincoln's SPY-6 radar does not register it for another 34 seconds. 34 seconds of a weapon already airborne, already closing, already solving the problem of where a 100,000-ton warship will be when the math runs out, and not a single system aboard that carrier aware it exists. When the SPY-6 finally finds it at 6:44, the contact is already 19 kilometers out. 40 seconds remaining. To understand why 40 seconds is a death sentence, you need to understand what the Hova actually is. Because this is not a ballistic missile that arcs above the atmosphere and announces itself on every radar in the theater from 300 kilometers away. This is not a drone formation that the formation watches assembling on the horizon for 30 minutes while the defensive picture develops. The Hova is a cruise missile built around a single engineering principle that separates it from almost everything else Iran has ever put in the air. It flies 8 meters above the water, not 80, not 30, 8, lower than the crest of a moderate ocean swell, low enough that the physical curvature of the Earth conceals it from every surface search radar in existence, because radar energy travels in straight lines and the ocean does not. A ship's radar antenna sits at a fixed elevation above the waterline. It can detect objects above a threshold called the radar horizon, the point where the Earth's surface curves below the antenna's line of sight. Anything flying beneath that threshold does not appear as a faint return. It does not appear as noise. It does not appear at all. It is as absent from every display in the formation as if the missile were sitting in a warehouse in Tehran. The Hova does not emerge from below the radar horizon gradually. It crosses the threshold and it is there, instantaneously, fully formed, already inside the threat envelope of every system designed to kill it. On this morning, given the sea state, the formation geometry, the antenna height of the SPY-6, that radar horizon sat at 19 kilometers. At 19 kilometers, flying at 1,000 kilometers per hour, the Hova has 40 seconds of existence on any radar display before it reaches the hull. The standard Aegis engagement sequence against a contact at 19 kilometers, closing at 1,000 kilometers per hour, requires a minimum of 28 seconds from first detection to intercept. That figure assumes ideal conditions. A contact flying cleanly above the sea surface, a fire control radar building a stable, uncontaminated track throughout the entire engagement sequence. The Hova does not fly cleanly above the sea surface. It flies 8 meters above it, which means every radar return it generates arrives contaminated by sea clutter, reflected from the wave faces directly beneath the missile's flight path. The fire control solution is not clean. The intercept geometry for an SM-6 descending toward a sea-skimming contact at close range puts the interceptor approaching from above, looking down through the same clutter band the missile is flying through. The probability numbers against that geometry are not numbers that get written into public briefings. 40 seconds, 28 seconds minimum, 12 seconds of margin against a contact. The fire control radar struggles to track, at a range where no ship in the formation has time to reposition, against a missile Iran built specifically to defeat every layer of carrier defense that existed before it. In the Abraham Lincoln's electronic warfare suite, Lieutenant Commander Reyes had been on watch for 3 hours when the contact appeared on her display at 6:44. She had been watching her passive sensor collection with an attention that had nothing to do with the watch schedule or standing orders, and everything to do with something she had noticed 22 minutes earlier at 6:22 that she had not been able to explain and had not been able to put down. A navigation data transmission, encrypted, periodic, broadcasting on a frequency indistinguishable from commercial maritime navigation traffic, coming from inside the strike group's own formation. She had flagged it at 6:22 as a possible equipment fault and left a monitoring window open on her secondary display while she continued working everything else. The transmission had gone out again at 6:23 and 30 seconds. Again at 6:25, again at 6:26 and 30 seconds, regular, precise. The exact timing of an automated system running on a fixed 90-second broadcast cycle. She had filed a low-priority equipment anomaly report at 6:31. It had not come back. The content of each transmission was navigational state data. position, heading, speed. The Abraham Lincoln's exact position, heading, and speed at 6:22, encoded in a standard commercial maritime format and transmitted on a commercial maritime frequency from somewhere inside the formation perimeter. She was looking at that monitoring window again at 6:44 when the SPY-6 contact alarm fired and the Hova appeared 19 kilometers out. She looked at both displays simultaneously for 4 seconds, the inbound contact on her primary screen, the navigation transmission still cycling on her secondary. The last broadcast had gone out at 6:43 and 51 seconds. The next one was due at 6:45 and 21 seconds. 4 seconds of looking at both displays at once, and then she understood what she was actually looking at. Not an equipment fault, a targeting feed. Someone inside the formation had been transmitting the Abraham Lincoln's exact position, heading, and speed to whoever held the Hova's launch authorization, not where the carrier was at the moment of launch, where it would be. Because a Hova does not fly toward where its target currently is. It flies toward where its target will be when the missile arrives, a predictive intercept solution. And a predictive intercept solution requires continuous, real-time navigation data from the target throughout the flight, because the target maneuvers and the solution drifts and the guidance has to correct. That navigation feed had been running for 22 minutes before the radar found the missile. The Hova had been airborne for 34 seconds before first detection, which meant it had 22 minutes of navigation history already processed into its guidance computer before it ever appeared on any display in the formation. It knew the Abraham Lincoln's heading. It knew its speed. It had been solving for the carrier's future position since before it left the launcher. It was not flying a bearing, it was flying a solution. 40 seconds became 31. In the Combat Information Center, the Aegis engagement sequence was already running. The system had classified the contact inside 4 seconds. The Tactical Action Officer had the SM-6 launch solution building. 2 interceptors assigned. Launch window opening. Reyes was on the circuit at 6:44 and 21 seconds. The missile has a predictive intercept solution. Someone in this formation has been transmitting our navigation data for the past 22 minutes. The missile is not homing on our current position from its own sensors. It has been given our position continuously. If we hold course and speed, its guidance solution is exact. We need to maneuver. Hard turn, any direction, anything that puts the hull somewhere the prediction does not account for. The response came back in 8 seconds. Who is this? What station are you calling from? Stand by. 31 seconds became 22. The first SM-6 launched at 6:44 and 24 seconds. The fire control solution was marginal from acquisition. A sea-skimming contact at close range against a clutter-saturated radar background, a fire control track that the sea return beneath the missile kept breaking and reacquiring. The interceptor climbed, turned, began its descent toward the intercept point the fire control computer had calculated from the contact's observed trajectory. The Hova was not flying the trajectory the fire control computer was modeling. It was flying the trajectory that a 22-minute navigation feed had enabled, aimed ahead of where the carrier was, ahead of where the fire control geometry predicted the intercept point would be. The SM-6 detonated 40 meters behind a missile that had already passed through the intercept basket. 22 seconds became 14. The second SM-6 was already in the air. The fire control computer had updated the solution based on the geometry of the first miss, but the update was built on the assumption that the contact was flying a standard approach profile. The Hova was not flying a standard approach profile. It was flying a predictive solution aimed at a carrier that was still on its original heading, because the Combat Information Center had not yet acted on Reyes's circuit call. The second interceptor detonated 28 meters behind a missile that had already moved through the kill zone. 14 seconds became 7. The close-in weapon system acquired the contact at 1.6 nautical miles. Against an 8-meter altitude target, the gun barrel has to depress below its optimal engagement arc into the clutter band the missile is flying through. The fire control radar kept losing and reacquiring the track as the wave return beneath the missile contaminated the return. 3 track breaks in 4 seconds. The system fired anyway, a single burst. The rounds reached the geometric intercept point. The Hova had corrected 2.1 degrees to the right in the final 3 seconds, updating on the navigation transmission that had gone out at 6:43 and 51 seconds. The burst hit the water 34 meters to the left of where the missile now was. 7 seconds became 4, nothing remaining. No SM-6s with time and bearing to intercept on this aspect. The close-in weapon system's engagement window had closed. The Abraham Lincoln was still on its original heading, a missile flying 8 meters above the Arabian Sea at 4 seconds from the hull with a guidance solution accurate to within meters, built from 22 minutes of continuous navigation data and nothing left between its warhead and the ship's side. In the Combat Information Center, every watchstander was looking at the same display. 1 inbound contact, 0 intercept assets with time remaining. 4 seconds. Rear Admiral Carver picked up the all-hands circuit. All hands brace for impact. The words went through every speaker on every deck simultaneously, through the engine spaces and the hangar bay and the mess decks and the berthing compartments and the passageways and the medical spaces and the forward machinery rooms. Through every compartment on a ship with 4,500 people aboard, all of whom heard the same 4 words at the same instant and understood precisely what those words meant. 3 seconds. Reyes had not stood by when the Combat Information Center told her to stand by. 2 seconds after her circuit call, she had begun transmitting a jamming signal on the navigation data frequency. Not at the missile, at the source feeding it, at the transmitter inside the formation that had been broadcasting the Abraham Lincoln's navigational state every 90 seconds for 22 minutes. The last transmission had gone out at 6:43 and 51 seconds. The next was scheduled for 6:45 and 21 seconds. Reyes had begun jamming at 6:44 and 23 seconds. The scheduled transmission never went out, but the Hova already had what it needed: 22 minutes of navigation history, a predictive solution built from that history, a guidance computer locked to a trajectory aimed at where the Abraham Lincoln would be if it held course and speed through impact. The jamming had come too late to corrupt the solution. The solution was already committed. The missile was already at 3 seconds, already descending toward 8 meters above the water, with nothing remaining between it and the hull. What the jamming had not come too late for was something Reyes had not calculated and could not have predicted. Something that required one specific action to happen in the next 2 seconds. An action she had no way of knowing was about to occur. The helmsman turned the ship, not because a maneuvering order came from the Combat Information Center, not because of anything Reyes had said on the circuit, because the helmsman on watch at 6:44, a second-class petty officer named Daniel Okafor, who had been at his station since 4 in the morning and had been on the Abraham Lincoln for 14 months, heard the all-hands announcement, looked at his wheel, and did the only thing he had left to do. He put it over hard to port, maximum rudder, not because any written procedure told him to, because the ship was 4 seconds from being hit and he was the helmsman and the wheel was in his hands. A Nimitz-class carrier making 28 knots under maximum rudder generates 340 meters of lateral displacement per minute. In the 3 seconds between when Okafor put the wheel over and when the Hova reached the hull, that displacement was 17 meters. The Hova's terminal guidance solution had been built from navigation data current as of 6:43 and 51 seconds. From that moment forward, the Abraham Lincoln had been on a steady heading. The missile's solution assumed it would still be on that heading at impact. It was not on that heading anymore. It had moved 17 meters to port in 3 seconds. The Hova impacted the Arabian Sea 34 meters off the Abraham Lincoln's port bow at 6:45 and 1 second. The 450-kilogram warhead detonated on water contact. The explosion sent a column of water 240 feet into the air. The pressure wave reached the hull in the same instant, hard enough to put 3 sailors on the deck in the forward passageways, hard enough to crack a hydraulic fitting in the Combat Information Center, hard enough to be felt in every compartment on every deck simultaneously. 34 meters. The hull was untouched. In the electronic warfare suite, Reyes was already on the second problem before the pressure wave had finished moving through the deck beneath her. The navigation data transmitter had been broadcasting from inside the formation for 22 minutes on a known frequency from a fixed position. Her direction-finding collection had been running the entire time, not because she had planned it, because she had left the monitoring window open at 6:22 when she first flagged the transmission, and the triangulation geometry had been accumulating passively across 22 minutes of continuous broadcasts. The source bearing resolved to USS Paxton, the fleet replenishment oiler operating on the Abraham Lincoln's starboard quarter in its standard formation slot. Closest ship in the group. Supposed to be routine, she transmitted the bearing, the frequency, and the complete 22-minute transmission archive to the Combat Information Center at 6:45 and 14 seconds. 13 seconds after the missile hit the water, the inquiry that followed located a transmitting device installed inside the Paxton's navigation suite during a port call in Bahrain 11 days before the engagement. The device was smaller than a standard paperback book. It drew power directly from the ship's own electrical distribution. It transmitted a compressed navigation data packet every 90 seconds on a frequency that every spectrum monitoring system in the formation interpreted as routine commercial maritime traffic, unless you were specifically watching for it the way Reyes had been watching for it from 6:22 onward. Iran had not been searching for the Abraham Lincoln. For 11 consecutive days, it had been receiving the carrier's exact position, heading, and speed every 90 seconds. Not just during the engagement, for 11 days, every course change, every replenishment evolution, every time the formation repositioned, all of it transmitted automatically, every 90 seconds, by a device the size of a paperback book, installed by someone with access to the Paxton's navigation spaces during a port call that was logged as uneventful. The Hova was the first weapon Iran fired using that data. It was also the last. The device was physically removed from the Paxton at 7:14. Every transmission it had ever sent was reconstructed from passive collection records going back 11 days. Every position, every heading, every speed the Abraham Lincoln had made good for 11 days was now a documented record. And everything Iran believed it knew about the carrier's patrol patterns, its operating areas, its replenishment timing, was intelligence derived from a device that was no longer transmitting. Rear Admiral Carver authorized 2 strikes at 7:22, the coastal battery that had launched the Hova, fixed by passive triangulation during the 34 seconds between launch and first radar detection, and an IRGC intelligence facility in Bandar Abbas assessed as the origin point for the device recovered from the Paxton. 4 Tomahawk cruise missiles launched at 7:23, 2 per target. The battery was gone by 8:01. The facility in Bandar Abbas by 8:04. In the electronic warfare suite, Reyes wrote her engagement log. Hova cruise missile detected at 19 kilometers, 40 seconds to impact. Navigation data feed identified as predictive guidance source at 6:44 and 21 seconds. Jamming initiated at 6:44 and 23 seconds. Contact impacted 34 meters off the port bow at 6:45 and 1 second. No hull damage, no casualties. She added 4 lines at the end that were not part of any standard engagement log format, and that Rear Admiral Carver kept in the final after-action report without changing a single word. Navigation data transmission source identified and reported at 6:45 and 14 seconds. Transmitting device located aboard USS Paxton. Full 11-day transmission archive recovered. Device removed at 7:14. Iran had the Abraham Lincoln's position every 90 seconds for 11 days. Iran fired its most capable anti-ship missile at a carrier it had been tracking continuously for nearly 2 weeks. A missile that carried no search radar of its own because it did not need one. A missile aimed not at where the ship was, but at where it would be. Guided in its final seconds by a position update transmitted from inside the formation's own perimeter 30 seconds before impact. 2 SM-6s behind it and in front of it. 1 close-in weapon burst to the left of it. 4 seconds remaining with nothing left to fire. It missed the hull by 34 meters because a helmsman with nothing else available put the wheel to the stop, and because a lieutenant commander had been watching a navigation frequency for 22 minutes that turned out to be the most consequential signal anyone collected that entire morning.